The question is, verify the double angle formulae sine 2 theta equals 2 sine theta cos theta and cos 2 theta equals cos squared theta minus sine squared theta for A, theta equals pi on 6, B, theta equals minus pi on 4, and C, theta equals 2 pi on 3. Now that word verify means to check. So for each formula, we need to sub the value of theta into both sides separately and see if they turn out to be the same. So what I'm going to have to do in order to find what the two sides of the formulas are is to find what sine theta and cos theta and sine 2 theta and cos 2 theta are, and then I can look at both sides of the formulas to see if they really are the same. So let's do A first. A, theta equals pi on 6. So sine theta is equal to sine of pi on 6. Now what's sine pi of 6? Pi on 6. I always remember that by drawing a little triangle. The triangle I draw for pi on 6 is half of an equilateral triangle. And I'll tell you why in a second. So here's my equilateral triangle. And I cut it in half down here. The reason I do that is because the angles in an equilateral triangle are all 60 degrees, which is pi on 3. So this angle in the top left-hand corner of my triangle is going to be pi on 3. So it's this triangle that I'm interested in. It's got a right angle here. This angle here is 60 degrees, which is pi on 3. This angle here is 30 degrees, which is pi on 6. So because it's a right angled triangle, I can find sine and cos of my angles by just using opposite over adjacent and those kinds of things. So let's just put in the lengths. The side length of my equilateral triangle is 2, which means that this bottom edge here is 1, being half of the side, and by Pythagoras' theorem the other short side would be the square root of 2 squared minus 1 squared, which comes out to root 3. This is the triangle I use in order to calculate sine and cos of pi on 6 and pi on 3. So sine of pi on 6 would be opposite over a hypotenuse. So pi on 6 is here, and the opposite side is here, and the adjacent side, the hypotenuse is here, so sine of pi on 6 is 1 over 2. Cos theta is cos pi on 6, which is adjacent over hypotenuse, and this time the adjacent side is here. So cos of pi on 6 would be root 3 on 2. Alright, let's find cos and sine of 2 theta now. Sine of 2 theta is sine of 2 times pi on 6, which would be pi on 3. So conveniently I can use this same triangle again to find sine pi on 3. Pi on 3 is here, and its opposite side is here, and the hypotenuse is here. So opposite over hypotenuse for sine gives me root 3 on 2 for sine pi on 3. Cos 2 theta is cos of pi on 3, which is adjacent over hypotenuse for pi on 3. So that would be the adjacent side here. Whoops. The adjacent side here. And so it would be 1 over 2. Alright, now I've got enough information to try and verify my formulas. Sine 2 theta is supposed to be 2 sine theta cos theta. So 2 sine theta cos theta is equal to 2 times sine theta is a half from above, times cos theta, which is root 3 on 2, and I can just cancel out some of these 2's to give me root 3 on 2, which from above is actually equal to sine 2 theta. So sine 2 theta is equal to 2 sine theta cos theta, for theta is equal to pi on 6. It's important to put that line in because it tells my reader that I've finished checking, verifying that formula. Let's do the other one. Cos 2 theta is supposed to be cos squared theta minus sine squared theta. So cos squared theta minus sine squared theta. Well, cos squared is actually cos theta squared. So that's cos theta squared minus sine theta squared. So cos theta is root 3 on 2. So we have root 3 on 2 squared minus sine theta, which was half squared. So I get 3/4 minus 1/4, which is 2/4, which is a half. And a half is cos 2 theta after all. So cos 2 theta is equal to cos squared theta minus sine squared theta, for theta is equal to pi on 6. So we verified both of them for theta equals pi on 6. Let's do the next one. I'll just start a new page. And we'll now do B. Theta is equal to minus pi on 4. Now, it's a negative angle, and to me the easiest way to figure out what sine and cos of that angle is to first locate which point on the unit circle that angle corresponds to. So here's a unit circle. There's the y-axis, there's the x-axis. And angles are measured from the x-axis anti-clockwise, but negative angles are measured from the x-axis clockwise. So minus pi on 4 must be down here. So it's in the 4th quadrant. What I do is from this point I draw a triangle back to the x-axis. And that's the triangle I use to figure out what sine and cos of my angle is. So sine and cos of minus pi on 4 are going to be related to sine and cos of pi on 4. So just to make that completely formal, sine theta is sine of minus pi on 4. Okay. So it's going to be sine of pi on 4 because that's the angle in that little triangle. But let's just check. All positive here, sine positive here, tan positive here, cos positive here. Sine is negative in the 4th quadrant, so it's going to be minus sine of pi on 4. Which just leaves me to find out what sine of pi on 4 is. And to do that I draw another triangle. This triangle's half of a square. So here's my square, and I cut it in half along the diagonal this time. So that leaves me with a right angle here, and with 45 degrees in each of those other two angles. So 45 degrees is pi on 4. Okay? My square has side length 1, so there's 1 here and 1 here. And by Pythagoras' theorem, we get the square root of 1 squared plus 1 squared, which is the square root of 2. So that's how I figure out what sine and cos of pi on 4 are. So sine of pi on 4 would be opposite over hypotenuse, which would be 1 over root 2. So we get minus 1 over root 2. Cos theta is cos of pi on 4, well, minus pi on 4. So using the angle in that triangle, it's going to be either plus or minus cos of pi on 4. And it says cos is positive in that quadrant, so I don't need to put a minus sign. Just to be absolutely certain, I can put a plus there. So Cos of pi on 4 is adjacent over hypotenuse, which again is 1 on root 2. Okay, now let me figure out cos 2 theta and sine 2 theta. I'll do sine first. Sine of 2 theta is sine of 2 times minus pi on 4, which would be minus pi on 2. Well, let's locate minus pi on 2 on our diagram of the unit circle. Minus pi on 2 is minus 90 degrees, which would produce this point here on the unit circle. Now, sine is the y-coordinate of that point. So I'm just going to draw in the coordinates of that point. That point would be 0 on the x-axis, minus 1 on the y-axis. So, sine is the y-coordinate of that point, so it must be minus 1. Cos 2 theta is cos of minus pi on 2, which is the x-coordinate of that point, which is 0. Okay, now I'm ready to check my formulas. So sine 2 theta is supposed to be 2 sine theta cos theta. 2 sine theta cos theta is equal to 2 times, and sine theta was minus 1 on root 2, and cos theta was plus 1 on root 2. Okay, so we get, on the top we get minus 2, and on the bottom we get root 2 times root 2, which is 2, so it comes out to minus 1. And just checking, sine of 2 theta is minus 1, so again sine 2 theta is equal to 2 sine theta cos theta for theta is equal to minus pi on 4. Alright, let's check the other one. We need to do cos squared theta minus sine squared theta. So let's see. Cos theta was 1 on root 2, so cos theta squared, minus sine theta, which was minus 1 on root 2 squared. So when we square those, we get a half minus a half, which is 0. And let's see, cos 2 theta down the bottom here is 0. So again, cos 2 theta is equal to cos squared theta minus sine squared theta for theta is equal to minus pi on 4. So we have one left to do. I'll start another new page and do C. Theta is equal to 2 pi on 3. So to figure out what sine and cos of that angle is, I should locate which point on the unit circle that angle corresponds to. So here's my unit circle. There's the y-axis, there's the x-axis. Pi is 180 degrees. And pi on 2 is 90 degrees. So 2/3 of pi is somewhere between half of pi and 1/2 of pi. So 2/3 of pi must be here. So we produce this point on the unit circle. The triangle we want to use in order to figure out our trig ratios is here. And the angle we have left in this spot just here is pi on 3, because we got 2/3 of pi, so we have 1/3 of pi left. So when we figure out sine and cos of 2 pi on 3, we're actually interested in what sine and cos of pi on 3 are. So let's see, sine of theta is sine of 2 pi on 3, which is sine of pi on 3, I should just check whether it's actually plus or minus sine pi on 3. So we have all sine, tan, cos. So up there in the second quadrant, sine is positive, so it's plus sine pi on 3. Okay, now we already figured out what sine pi on 3 was before. I'll just draw that triangle again. So it was 1, 2, root 3. Here's pi on 3. Just there. So pi on 3, sine pi on 3 was opposite over hypotenuse, so that's root 3 on 2. Cos of theta is equal to cos of 2 pi on 3, which is cos of pi on 3, because pi on 3 is the angle in the triangle that I've drawn in the unit circle. And let's just check. Sine is the only positive one in the second quadrant, so it must be minus cos of pi on 3. So we get minus cos of pi on 3 would be adjacent over hypotenuse, which would be 1 over 2. Let's find cos and sine of 2 theta. Sine of 2 theta would be sine of 2 times pi on 3, 2 pi on 3, which would be 4 pi on 3. In order to find that, I need to locate 4 pi on 3, the point on the unit circle that angle corresponds to. So let's draw another unit circle. There's y-axis, there's the x-axis. Now, pi is here, that angle there, and 4 pi on 3 is 1 1/3 pi, so we go all the way around and we do a little bit more just here. So there's my 4 pi on 3. Here's the triangle I'm interested in, just here. Go back, draw your triangle back to the x-axis. And the angle in my triangle that I'm interested in is just here. And that angle again is pi on 3, because I have 1 pi plus 1/3 of pi. So it's going to be the same as sine of pi on 3, because pi on 3 is the angle in the triangle in the unit circle. But we just have to check to see whether it's plus or minus. All sine, tan, cos. Tan is the only positive one here in the third quadrant, so it must be minus sine of pi on 3. So sine of pi on 3 was root 3 on 2. So we get this. Cos of 2 theta would be cos of 4 pi on 3. Which again, we're using this triangle that we've just drawn, and that's the angle in that triangle is pi on 3. And cos is negative in the third quadrant, so it's minus cos of pi on 3. So that would be minus a half. Okay, now we're ready to actually check our formulas. Sine 2 theta is supposed to be 2 sine theta cos theta, so 2 sine theta cos theta is equal to 2 times root 3 on 2 times minus a half, which is, we can cancel those, at least these ones, so that would be minus root 3 on 2. And let's just check, sine of 2 theta was minus root 3 on 2, so sine 2 theta is equal to 2 sine theta cos theta. 4 theta is equal to 2 pi on 3. Let's do the other one now. We want cos squared theta minus sine squared theta, which would be cos theta, which was minus a half, squared, minus sine theta, which was root 3 on 2 squared. So we get a quarter minus 3/4 which is minus a half, which actually is cos 2 theta. So cos 2 theta is equal to cos squared theta minus sine squared theta, for theta is equal to 2 pi on 3. So we've verified both formulas for all three of our angles. That's the end of the question.